In a previous video series, we introduced the notion of an object. Objects were these values that contained other additional things inside of them. Things like attributes, which were variables. And they also had methods. So method calls kind of worked like function calls, but the first argument was always written before the method name. So here we have the method clamp, and the first argument is the object p, and I haven't put it inside of the parentheses. Instead, I put it in front. Now, in a much older video series, we mentioned that strings also have methods, and they were kind of unusual in that regard. So that raises an interesting question. Are strings objects? Well, that's a really good question, because surprise, everything is an object. To see what I mean, let's go look at the Python tutor. So here I have the Python tutor, and I'm going to look at a normal object. I'm going to visualize it. I have a constructor call, and what happens when I do this is, well, it creates a folder. But it doesn't put the folder inside of the variable p. Instead, p only contains the name of the folder. It's referring to the folder. Now, when we worked with the basic types like int, float, boolean, and string, and we assigned them to a variable, well, we just stuck that inside of the box. So if I assign abc to a string, or to a variable s, it's going to create s, and it's going to put abc inside of it. If I take the integer 10,000 and I assign it to x, well, it's going to put that inside of the box. This is a lie. The Python tutor has been lying to you. I have been lying to you all semester long. To see what I mean by that, I'm going to go click this box right here that says heap primitives. And I'm now going to click visualize to see what really happens. So if I assign the string abc to s, what happens is Python creates a folder. That folder contains only abc in it. And then that folder has a name. So it puts the name of the folder inside of S, not the string, the name. Same thing for 10,000. If I assign 10,000 to X, what does it do? It creates a folder with 10,000 inside of it, and it puts the name of that folder inside of X. Don't believe me? Let's just go over to Python here. I'm going to assign ABC to S. What is the ID of S? That's the name of the folder. X is equal to 10,000. That's the ID of that folder. Y is equal to 10,000. We think that's the same number, but look at that. That is a completely different folder that has 10,000 in it. Wow. What's going on here? Well, remember we saw when we were looking at types like int, Python said that they were a class. This is a design decision in Python 3. Every single thing, every single value in Python 3 is an object, and every single type is a class. And in fact, remember, how do we actually create objects in Python? Well, we had this special function, the constructor function, that was the same name as a type that we used to create it. But we also have these functions that are the same names as the primitive types, like say int, that can convert anything to an integer. That's also a constructor function. All of these things are the same thing. Why did Python do this? Well, it makes it easier for processing. It makes things easier underneath the hood. But man, as you can see, it's going to make learning a lot more complicated. Objects were hard enough as it is, and now you've told me that all the primitive types like int and boolean and float and string are a lie. Well, that's okay, because we're going to continue to lie to you. And that's because lying really isn't that bad. Why is that? Well, let's go look at these folders again. What we'll notice is missing. I don't have any attributes there. There are no variables inside of this folder. And what that means is it is impossible to reach inside of the folder. These objects are immutable in the same way that we talk about immutable functions. I can never change the contents of the folder. Now you might say, what do you mean by that, right? I could take Y, so Y is currently a folder, and I can always add 1 to it, right? So I've now changed the value of Y, right? Except what you did when you added 1 was you made a brand new folder with a different ID. That original folder that contained the 10,000, it's completely unaffected. And that's the big deal, right? The only reason why we care about folders in this class is because for objects, I can reach inside of the folder and change them. I can't change any of the folders for the basic types like int, float, boolean, or string. And since I can't change them, why bother even drawing them? I mean, look, it's just a metaphor anyway. I mean, I'm trying to somewhat think like what Python does, but nothing that I do is completely accurate. If I can't change it, I'll just pretend that the folder doesn't exist. And so that's what we're going to continue to do. We are never going to click this button that says heap primitives. And whenever we draw a variable that contains an int, a float, a boolean, or a string, we are never going to draw that folder. Because as far as we're concerned, the folder doesn't exist. Okay, fine. So why did I start to scare everybody with all of this? Well, look, even though it's true that we're never going to draw the folders, what I've just said about everything being an object has some other important ramifications. Now, everything that I'm going to talk about in this video series is fairly advanced, and for the most part, the typical programmer in 1110 doesn't really need to use any of this stuff while they're programming. But you probably need to be aware of it because you might use it by accident. Because remember, when you do anything wrong, Python is going to give you an error message that tells you what you did wrong. And if you don't accurately understand how Python thinks, well, you're not actually going to be able to read these error messages. So that's really the point of this video series. We're going to completely pull off the lid and really question everything that we think we know about Python. But ultimately, the goal is to have a better understanding so that we can read the error messages that Python gives us.